Hey, can you all hear me? Is this working? Let's see. Okay, great. Guess we will get started then. All right, let's see. So, guess we have a couple minutes here. We'll see if anyone else shows up. Everyone having a good Saturday? Okay. I think the stream settings are set to, yeah. Maybe I should reduce the latency on this a little bit, but yeah, next time. Okay. Let's see. Yeah, so I guess it's about time. I don't know if actually I don't know how many of you have seen the previous stream, but it was pretty long, so I might not necessarily recommend it that much, but it was definitely fun. Okay, so it's 1:30 now. Let's go ahead. Okay, so I think for those of you who were not here last time, which is probably most of you, um, this is Refraction Racer, which is basically a little racing game where you have a vehicle, a little spaceship, which kind of bounces around based on refraction. So essentially, all we're doing, which we covered this last time, but all we're doing is we're using something called Snell's Law, which is this thing right here. So you have some input vector and you have some output vector, and their ratio or basically the angles are proportional to the index of refraction. Or, yeah, that sounds right. Yeah, Levi, I know you watched the whole thing. Um, let's see. Okay, so cool. And so basically, we have a simple implementation of this, which is this all visible or is it a little bit too small? I don't know. We can also switch to the view of this directly. Um, so right now we just have like this little triangle, and I figured maybe the first thing we can do today is to shade the polygons. So maybe first step, we'll just draw more than just the one triangle. And we'll go to here, and we'll just add a new polygon just to kind of have something. Do polygon.new. Wow, if I can type. And we'll just do 5.times and .map. And this way we can create... Oh, I didn't go over the code base at all. Okay, so this is the code base. So essentially we have these ticks. This is ticks, and then we call a setup function here. This is our setup. This is basically only run on first run, and then we also we render the spaceship to a render target. So that's over here. And so right now it's basically just this little very simple shape. And then beyond that, we have our inputs that we process here. And right now it's just left and right keys and the up arrow to basically move in the direction that we're going. We also have this update state, which is where we basically process everything. So that's where we do our refraction. And then we have the render. And all this is available on my GitHub, which is on github.com/coda-on-git. And I have a Dragon Ruby resources page here as well. Okay, and then under here, I think maybe under streams, yeah, here it is. So this is just up to date to, and basically I'm picking off from where I left off last time, except for that there are two changes that I made. There were a couple bugs, or there was one bug here where I was changing the position rather than the velocity. So that's why the refraction wasn't working quite right, but that's fixed, and then that allowed me to reduce to more realistic refraction values. Okay, so now we'll just draw the polygon. We'll make this a pentagon of sorts. And I guess we don't need an index, but we can do vec2.new, and we'll do rand times 1280 and rand times 720, and that should give us, hopefully, did that give us the right thing? Maybe not. Okay, I might already be off to a bad start here. Okay, so map. Oh, wait, no, this is set up, so I need to hit backspace here. And now we have a random polygon, so this is a pentagon, and if we hit backspace again, oh, right, because the random seed is the same. So we'll, now we have a simple thing which lets us generate a random polygon, and we can actually wrap this in a function. Polygon, and we'll have this just return a polygon, polygon.new, and we'll say num sides for the number of sides, and by default this will be 4, but we can randomize this, and then so polygon.new, so say I'll just copy this from up here, and instead of being 5.times, I'll do num sides. And then for this, instead of using the triangle that I had at first, we will do, I don't know, maybe we'll create 10 of these. And we'll do a random int. So generate polygon on, is it integer? Int? Oh, wait, no, I can just do it .2i or around, I guess. So we'll do rand times, 4 plus 1. Or is there a rand int, maybe? I thought there was a rand int. rand, this is fine. Dot to I, and now presumably, unless I'm being, yep, okay, so now we have a bunch of these things. It does need a minimum of 3, so I think rand is from 0 to 1, so this will give us anywhere from 3 to 7 sides, or 3 to 8 sides. And now we have a bunch of these polygons, and they're all, that's a huge mess. Okay, we might reduce the number a little bit here. We'll just make 3 at first. It does not like me. Okay, here we go. Okay, so now we have these polygons. They have random number of sides, and now let's fill them in. So all we need to do for that is we're going to take this pretty simple approach. So let's say we have some polygon, looks like this. So we're going to first look at kind of the bounding box here. And this we're just going to take by computing the min along all the x values and the min along all the y values, as well as the max along all the x and max along all the y values. And that gives us this point and this point. And from that we can create a bounding box. Now along each of these, what we're going to do is we're going to go up, or maybe sideways is fine too. So we'll go up, I guess, and we'll start with a y value of 0, and we'll have y of, or I guess, yeah, y equals 0, and then y equals, max y. Maybe we'll make this min y over here. Can you all see that? Oh, maybe there's some stuff that's, yeah. When I'm drawing things, it's just always a little bit tricky to get this right. Okay. And so essentially what we're going to be doing is we'll be drawing lines this way and computing where we have intersections with the polygon. And then we'll just use the outputs lines onto a render target to draw the polygon. Okay. So last time we created a little function to compute intersections. So this is here. And I think we went over this in a lot of detail last time. But essentially what we're doing is we take we have 2 points or 2 line segments that we define by the point, the starting point, and then a vector which is from that point to the second point here. So instead of basically computing via subtracting 2 points or that kind of thing, what we do is, instead of basically using 2 points to define a line segment, we define it as the line segment and then the distance or the offset to the next point. And then we have these t and u values where if t equals 1, then we end up having a point at this. We have the intersection here, and if t equals 0, it's here. So t basically is a sliding scale, which is why in this little algorithm, you can check for whether it's inside of a line segment versus outside of it. So this little Stack Overflow post is fantastic. It does a great example. But I won't be going over it today. Okay, so anyway, why don't we draw the render target then? So we have a polygon method of sorts. Oh, and we also have a volume, which which I guess is more what is a volume? No, okay, we're not using that yet. Okay. Well, for now we can just stick it in Polygon and we'll move it later. So we can have a render, which is we'll have it called generate render target. And we'll have some sort of label for this. And so pass in an args. And I guess for this, we'll need to pass in args as well, and we'll have a label. And we'll just push that all in here. So we set the points, and then we render it. And actually, why don't we just do something like this, and instead of passing in the label, we'll have it always be rendering or generating on the same render target here. Okay, so now we do args.outputs. Am I doing this right? Args.render target. Wow, okay. I am definitely, you can tell I've been too busy to look at this stuff for a little bit here. Render target. Okay. Yeah, so args render target. And then we'll just specify what we want here. So args render target. And we'll call this label. And for now, we'll just have this little thing here as a shortcut. Do we need that? Maybe we don't. Output symbol. Oh, is that... Levi, is that a little trick there that I am not familiar with? It might be. Ah, yes, okay. Outputs, scene, background color. Is that a shortcut for render targets? Or is that... Of course, this is one of those cases where I don't see it being documented. Okay, well that's interesting. Maybe that sounds like a better way to do it. All right, we'll do... Yeah. Do you know what the difference is between outputs at label versus render target? Are these the same thing? You know, so I don't know. I'm familiar with render targets, so maybe I'll just do that for now. I'll definitely look into that though. That's very cool. Okay, so we have this running, and then we do want to draw to it, so I think just lines is fine here. And for now, we don't have this computed, so we actually need to first compute the intersections, which should just be a matter of, so we have our at points, and then what we're going to do is basically draw all the lines, or look at all the lines here, which I think we have a display function here, which we do something very similar. So we're just going to do a zip and a rotate, which basically takes the inner array and yeah, I think, Levi, this does work on just strings or whatever else. So at least I think it's just a hash under the hood. So it should in theory work with everything. Okay, so display debug. We have the zip, which allows us to basically define all the lines. So that's how we get the rendering of the lines here. So we'll do kind of the same thing here. dot zip on at points dot rotate 1. And then now we can do each point 1 and point 2 is, I believe, all we need here. Is that right? Yeah. So these are our two vectors. And so now we're also going to find the minimum points in the x and y direction. I don't know if we... Okay, we did not create a function for that last time, but that's okay. So we'll just do this here. So the minimum x value here, actually, why don't we add a def get min max points. We'll have a points, and then we'll do min x equals points dot, let's see, there is a min max, I believe, in Ruby. Min max. Let's take a look. Ruby. And yeah, so this guy right here, and this is what we'll be using here. So essentially all I need to do is pass in a block and a comparison here. So this is typically what we do. So we'll be doing exactly that. And that gives us both the minimum and the maximum values. So what we can do is max x is min max on do, or maybe we'll use this syntax instead, ab a dot x b dot x, and I believe that gives us our minimum maximum in the x direction, and we'll do the same thing in the y. And then we'll create new vectors. So vec2, and how did I do this before? Okay. Vec2 dot new min x min y, and then vec2 dot new max x x max y. Okay, and now we have a little min-max function, which if we only have one polygon, we can test out very easily. So get min-max points on args.state.polygons. We'll just do the first one here, dot points. And I hope that doesn't crash on me. No, we're okay. We will refresh that though. Actually, this is in the setup, which I don't want to. I want to be running this over here. This is just for debugging purposes here. Why does it only want... Okay, I'm gonna kill that and start up again. See if that works. Oh, okay, well it doesn't like me for some reason. Oh, for dot times dot map. Non-float value 53. Oh, this thing seems to be when I use the reset function that doesn't like me. Okay, so what's going on here? We have wrong number of arguments. 4 times dot 2a maybe? Does that like me better? Looks like... Oh, right. I did change my initialization. Very good. Okay, generate polygon. So we have, let's take a look at what I changed that to. Initialize on polygon. So we have our args and a label. Numsides dot times dot map. Okay. So here we'll have our label B, just the count, and that's fine. And we'll pass in args as well. Generate polygon. And then in here we'll have do I think we can get rid of that. Does for.map work directly? Maybe it does. Args, and our label is just going to be I. And then when we refresh it, it still errors for some reason, but I think if I start it from fresh, it's fine. Yeah. Okay, cool. For.times map. So if we switch this to 1, and then we do that, you can see it created some polygon, and then we can try rendering just the bounding box here. Or I guess we can just do args.outputs.labels, and then we'll just add this somewhere. And then text is this. And of course, vec2 doesn't have a serialization, so we will add that in. Class vec2. Oh wait, no, we do have a .2s here. Serialize. Oh, right. Okay. This thing. I have an unexpected end. Wow, on a roll today. Let's see, maybe process inputs, update state, generate polygon. Oh, it's because I just started typing things, isn't it? I did not think this through. Compute, test. Okay. Yeah, I did forget an end somewhere. But the real question is where? Where did I forget an end? We have generate polygon looks okay. Where does the error happen? Line 15, so it's right at the top here. I bet it's parentheses. It's always parentheses. Yeah, okay. So I just needed the parentheses there, which makes sense. Okay, so we have this stuff, which doesn't really help. And then we'll just do join works, right? No, dot inject. We'll just put this on a new line here. S value, or we'll just do S, and then we'll have B, and that might work. Dot round does not exist on this. Huh. Oh, actually, this is somewhere else. Dot round. Okay. Yeah, maybe the inject should work, right? I think. Oh, it's a parenthesis here again. Same thing. It's always the parentheses. Okay. So now, if we do S and V, syntax error, another end somewhere. Okay. Let's see. So we have the sum. Yeah, maybe I'll stop the inject. Wow. Okay. All right. We'll just go old school. Max points equals get min max points arg state polygons 0 dot points. And then we will, okay, min max points. Now we'll just have a for loop, or I guess just print out args.outputs.solids, and we'll have an x on min max points 0 dot x and y be min max points 0 dot y. X2 is going to actually be the difference between these. So 1 dot x minus min max points 0 dot x, or this is, I'm sorry, this is the width. And the height is the same thing, so we'll just copy this over, and we will use y instead. And we have a syntax error because of all this stuff. And then x, y, with height. Okay, so something isn't quite working. Let's actually put this. X2 is not a thing. So there's an issue here. vec2.new, we can just specify points that way, but our min-max points isn't giving us what we want here. So min-x, does that at least print something out? Oh, right, yes, okay. So this gives us the minimum point and the maximum point. So I think what we actually need is, these are actually vectors. And that's our problem. Okay, and then this will be dot x, dot y. Yeah, okay. Okay, there we go. So now this has kind of filled it in. We're going to get rid of all those buts because they are very annoying. And now presumably we have something which is not visible. So we'll just do alpha of, 10. And now we see the bounding box around here. Okay, so yeah, we can keep this in here for now. Yeah, that was only the alpha value, but we'll do 255 here, and now it's red. Okay, So let's do the polygon. Oh, there's going to be something weird here where the normals are actually off based on whether you're inside or outside on this when there's an intersection. Maybe the easiest way to handle this is to not allow this kind of thing, but I guess we don't need to worry about that now. Okay. Refraction, display. We were filling in the polygons. This has been slow going today. Okay, so we have a render target, and we now want we have our min-max, so get min-max points, and we have at points, and I think that's all it is, min-x, or min point and max point equals that. So that gives us our bounding box. Now, for what we want is max point dot y minus min point dot y, and we're going to convert this to an integer dot times do y value, and or actually what we so what we'll do is go from 0 to the maximum value, I guess. Does that make sense? No. Why don't we actually do it the other way? Yes. Okay. So we'll do min point dot y dot 2I dot up to max point dot y dot 2I plus 1 dot times, or no, not dot times, and this will give us our y value that we're looking at, and our x will just be value will just be our minimum, and our width equals max point dot y minus min point dot y dot x. Yes. And now what we have is a width section here. So what we'll do is bring up the intersection code. So we have our P and Q, and from what we saw earlier, Stack Overflow, this is this one here. So we have P and a Q defined as our starting points, and we have these vectors here. So our P value is equal to min point dot x, and then we'll use our y value here. And then r is always just going to be the exact same thing, so we could actually define it up above, but that's okay. 0. So this is just the width, so we're just drawing a line sideways here. So this is just going to be this line here. That's what we just defined. Okay. And then our Q value will be, and here's actually where we use this thing. So for each of the points, our Q and R value, or each of our line segments, our Q and R values will be different. So point 1 dot let's see, yes, so this is just 0.1, and r equals 0.2 minus 0.1, and that should do it. And 61, it does not like me. This may or may not just be the same thing again. Yeah, okay, so we're okay here. So we now have this, and then we're gonna compute intersect on all of these. So P, R, Q, and S. And this gives us our, I think just whether there's an intersection, right? Or no, it actually returns the point. So instead of doing a zip, what we'll do is we'll do instead of doing an each, we'll do a map, and this will give us our intersects. And then we can do dot sort. And I think all we need to do for that is sort Ruby. So there's this nice sort function. I think it's the same kind of thing where we just, specify this. So we'll just sort based on the x direction. So A and B. And I guess we can just sort this in place. Is that right? Yep. I guess there's a sort by, but I think that only works on hashes. That sounds correct. Okay, so intersects.sort, and then we do a .x, b.x. And now we have this sorted, and we can also draw, why don't we draw all the points that, or yeah, so that's okay. args.outputs. So this is going to actually be pretty slow, but we'll just draw this anyway. So a dot or intersects dot each do point, and then we'll do args.solids.outputs or args.outputs.solids, and we'll do point.x, point.y. We'll just make them 5 by 5, and then we don't get any intersections. Why is that? Because we only draw it for a split second. Okay, so that's gonna be, I need to draw this to the render target. And then we will display this down here at points. Yeah, okay, so args.outputs.sprites, and then we'll do path, and this path will be at label, and our x we'll just have as well, actually, what happens if we just, we'll just make this 100 and y 100, and just do, I'm not sure if, do I need the source width and height for this to work? Maybe I do. X of, I think I actually need to compute the minimum, or no, I guess this doesn't matter at all where this is, but our width has to be, just make this 100. Source X. So what we're actually going to do here is we're going to shift this. So render target. Point.x minus min point.x minus min point.y, and that will shift it down. And then our source x will be 0, source y is 0. We can just use the full canvas for now, and that'll be good enough. And I still have something going on here. Not handled for nil 18. So I definitely... the case where we don't actually have... Oh, no, I think maybe I just need to restart that, and now the error's somewhere else. Okay. So many errors today. All right. Let's see, 232. So our compute intersect didn't work. Because tick 0, generate render target. Invocation failed. There's an error up above. Unhandled. This method was invoked there. Sometimes I have so much trouble with the drgtk errors. I have P, Q, R. You say I have... Oh, I see. Yes. Okay. And now I presumably have something else going on. Yeah, so now I have S defined correctly, right? So PRQS, and then we have line 234 it's complaining about, which is this guy. So I guess this is if intersects is nil. Dot nil. Something kind of like that. And there's definitely still an error. Vec 2 does not support serialization. 235. Comparison of nil and nil failed. So why don't we actually just say if... Wait, why is this nil? Intersects map. So we have this compute intersect. And if this is nil, so we need a dot compact. So many errors. Okay, now we don't have any errors. Okay, that's good. And you can see the little box down there, which is very small. So what we want is we'll have a parameter, which I guess, actually by default, if I don't specify a source width, it uses the... Yeah, it does it correctly, I guess. So if we set this instead to like 300 by 300, we should see something bigger. Okay, cool. So here basically are all the points along this that are intersected. And then what we're going to do is kind of a very simple approach to figure out whether we want to draw or not. So there's a theorem or something, which is basically that whenever you draw a line through a polygon, as long as it's not at the point itself, or at the points of that define the polygon themselves, there's always going to be two Well, yeah, there's always going to be an even number of intersecting points. So let's take a look at a case like this. So we have some, you know, something like this, right? So if we're drawing a line through this, um, at this point, we have one intersection, we have, so, you know, this is 1, 2, 3, 4. And no matter how you draw these lines, you're always going to have an even number at the end here. So basically what we want to do is whenever we have an odd number for this count, infinity is even. Yes, it's of course always even. It's also odd, but okay. So yeah, so no matter which direction we draw this from, so if we draw any line like this, is always going to have, or any polygon has this property, at least in Euclidean geometry. I cannot speak for other forms, but at least any closed polygon, regardless of whether it's concave or convex, or whether it intersects with itself, they all have this property. So that's very convenient for us, because all this means we need to do is have a little thing which just says, should we draw or should we not? And let's see. So we have we'll go back to the render target here. And in here, all we need to do is actually kind of pair them off, I guess. So there's a nice little way to do this, which intersects dot, I think was it slice, which gives us 2 array. There's something. Slice. What does slice do for us? Oh, no. Slice is very clearly wrong. But there's a great little trick that you can use. Intersect min max. Levi, you don't know, right? Shift. So basically what I want is to pair up every 2. And then every other time we'll just skip 1. So there is Ruby array pairs, consecutive pairs, that's what we want. Each slice. Yes. So each slice gives us, each slice is a super cool function. It's possible I talked about it last time too. Nope, I did not probably. So what each slice does, each cons. No, so each cons does 2, where it would pair up 0 and 1, and then 1 and 2, and then 2 and 3. But what each slice 2 would do is give us just the lines that we want. Yep. So what we can do is each slice on 2, and we'll do, yeah, that's right. And so yeah, so that gives us intersection pairs. Sounds good. Dot labels, or dot line. And we will have our first point and second point. So p1.x is x, p, and then our y is p1.y, x2, p1 or p2.x, and y2 is p2.y. And I believe that should be all we need. And this will actually break up parts because of nil, but now we have a polygon drawing thing. So we can do, we can add a different color to this. We'll set the alpha value to something a little bit smaller, and then the next thing we need to do is draw it in the right place as well. 50 is a little bit too light. Do 150. We'll make this blue for now, since we don't care. Okay, so now here we have this shape, and then we also draw it over here. And that could have, yeah, so that's pretty simple. Label, so we'll have the width, or x equals, okay, max point equals get min max points at points, and then at x equals min point dot x, and then so we'll just do y minus min point dot y, or this should be x, sorry. And now we have this, and we can actually, I guess, shift this to be just taking at w here. We can pull this out, so we don't need to recompute it every time. This is at x, and then we can do at y, and this is at y plus at height dot 2i, and that gives us a version which I think doesn't rely on these variables. Okay, cool. So now they're instead a property of this, and we'll add in something like this. Okay. So now when we display this, we will just use the at x and at y here, and we'll use at height and at width over here. And that didn't give us the right values. Why did it not give us the right values? Source, oh. Something's not quite right. Oh, right, because source x should be at x and source y should be at y. And then I guess we can just do, man. All right, so at least now we have drawing of polygons. And then now we have, for example, a higher number of polygons. So we have in our setup, we can create 4 polygons, and that instead will look something like that. So now when we drive our little spaceship through this, it bounces around even though I'm only hitting the up arrow right now. Okay, So maybe the next thing I'm gonna do, and I probably won't go for too much longer, since it's been going for an hour and a half, and clearly I haven't been on my A game per se. But what we can do is add a maximum velocity, which we currently don't limit, I believe. Is that true? Vel max um max x vel vec. Yeah, sorry, I know it shouldn't have taken that long to get to this point, but at least it works. So that's good. But yeah, why don't we just puts this for now? Outputs dot labels. Yeah, so we'll just put this somewhere. Text current vel is args.state.spaceship.vel.round, and we'll do just 2 here. And of course that doesn't want to work because we need the magnitude. And still doesn't like me because this is in the setup function. No, it is not because it's in the setup function, but this is also the wrong place. So right now I am, where am I rendering this? Outputs dot, is it output? Oh no, wait, args.state, of course. Yeah, okay, so now we have our velocity, and you can see it's unbounded. So we're just gonna adjust that so that we can't do that. Velocity. So we'll have a max vel. And I guess maybe that will be, I don't know, what's a reasonable value? It's going pretty fast right now, but we'll set this to 60, I guess. And we have our current vel. So we multiply, we have the force that we apply. So we have this guy here. And how we're going to handle this, I think, is if args.state.spaceship.vel.mag is greater than args.state. Or spaceship max linear vel, then we will be doing args.state.spaceship.vel divided by equals, and I'm not sure that actually is valid right now, but we'll take a look. And then we'll do args.state.spaceship.max linear vel equals args.state.spaceship.vel.magnitude. Okay, so what we want is to divide this by the current magnitude and multiply by the new one that we want. Oh, yeah. No, I can't just clamp it because this is a vector, so we need to actually scale the vector instead of just, yeah, flat out clamping it. Since we're dealing with x and y values instead. Yeah, so right now this has a maximum of 60, which is obviously too slow. So we'll increase that to something like 200, and we'll try that out. And that looks a little bit better. I guess different ships will have different velocities or something, but yeah, sometimes these vectors can be a little bit tricky because you have to think about. So essentially what we're doing is we're multiplying the maximum velocity that we want by the normal vector of our velocity, or normal vector, normalized vector, not normal vector. Yeah. Cool. So we have that working for us. And I guess we'll increase the force a little bit because this seems a little bit hard to use. So there's the max force, and I guess we right now just have this specified here. Let's try like 2000 for a value here. Oh, there we go. So that feels a lot snappier. Then we'll probably increase the max velocity a little bit as well. And then one of the things that we're going to do is, depending on the amount of refraction that you have, increase the velocity beyond the limit, but maybe not today. Today we'll just play around a little bit with this and then maybe call it a day at that. Also, I want to render in a different order, but now that we have polygon rendering, though, we can do something a little bit more interesting with the ship as well, rather than just its current. Yeah. Okay, so actually first thing I want to do is just reorder the rendering. So there's the render. I have a display function, I guess, which is where I have all this stuff. And I'll just put the polygons underneath the spaceship. And now it's a little bit easier to see. Okay. So that actually feels decent. I think I want to up this value a touch, maybe. Make it 25% more. 20%. Yeah, okay, there we go. So now this thing will be a lot. Yeah. Cool. So I wonder, is there anything else that we wanted to do today? Maybe that's a good place to stop for today. So I guess basically just all we did was draw in the polygons. I apologize, that took a lot longer than it should have, but you know, but now we have polygon rendering, and then we'll just have them. Ooh, actually, do I want to shift them? We can worry about that next time. All right, cool. So thanks for watching, and I'll just post this stuff on my GitHub, and you can take a look at it. You can steal this code, since that's kind of why I'm writing it anyway. And yeah, thanks for watching.